everyone. We are a team of mechatronics students, and in this presentation, we'd like to show you our final project. Before we begin, let me introduce our team. Dainer Rodrigo José González, Andrés Pérez Mancilla, Jesús Edgardo Briones Torres, Walter Reyes Pérez, and myself, Facundo Fabián Pérez Ramirez. Now let's get into the project. It's a fully mechanical system that automatically transfers marker caps from point A to point B. This kind of task is usually done manually, but we wanted to improve it using automation. Production lines used to rely on repetitive human motion, but now with mechanical solutions like ours, those tasks can be done more efficiently. Our goal was to automate the process without relying on electronics. No sensors, no microcontrollers, no programming. Use pure mechanics, cams, gears, and articulated arms. In this project, I took on the role of team lead, supervising the technical design, research, and simulation. I coordinated the investigation of components, how to integrate them properly, and the selection of materials. At the same time, I guided the modeling and simulation process, making sure the mechanics worked smoothly and reliably. Of course, this was a team effort, and each member contributed in different areas. Uh, Now we'd like to walk you through how the system works and how we made it possible. Next.
Hello. Um, all right, let's talk about the mind part of the mechanics. Our system works with for the moving arms. Each one careful designed to grab the plastic cuts. Uh, Move the alarm at the set pass and let them go at the specific spot. The plastic caps we use are 23.1 millimeters tall. They are not very big, but because of their size, we need to control them careful. We have to make sure uh, the calf stay completely s- stable during the usual process. If they tilt, shake, or move of the planes and the joint system code stem working, that we keeping the staging and the inlet out is super important. Uh, to move the arms, we use our rolling cam. This arcade mechanical part then tour spinning motion in the steering motion. As the car is spinning, the push each arm in the certain order and the right time. This timing matters a lot. It makes sure every arm does its job at the exact right moment. This helps and caps move smoothly from one the stiff of the next. Or one of the best things about the systems is that the install by the width and the right world. We don't need a complicated electronic and sensors. Instead, mm, everything moves using just mechanical parts. Um, that makes it easy to take care and very reliable. Uh, w- Once the camp start turning, the system runs by Yusuf in the loop. The arms keep doing to grab the moves in the instead automatically. This not stop cycle makes it perfect for doing to the same task many times. In short, this whole system gives the precision, simply and automation. Everything works together. Next.
Hello, my friend. My name is Jesus Edgardo Briones Torres. The part I'm going to explain talks about the gear train used for mechanism. For this year train, the following consideration will take into account. To make the system work, we had to reduce the speed of the motor and increase the torque. That we built a gear train with three stages. The motor starts at 227 revolutions per minute, and the final output is about 6 revolutions per minute. At the same time, the torque is increased from the 20 newton centimeters to over 600 newton centimeters. The tire power is transferred to the cam. We use a different gear size into each stage. For example, the first gear part has a 5 to 1 radio. The second stage is a 3 to 1, and the last one is the 2.5 to 1. We also select the pressure and angle of the 20 degrees and diameter pitch of the 20, and material likes is PLA plus uh, or nylon. These parameters help it create a smooth rhythm and movement. Yes. This is one of the fundamental parts of the mechanisms as it will generate movement without it. The motor we consider is a commercial motor. Otherwise, the mechanism will be even more expensive. The next page, please. The next frame.
I am Andres Pérez Mancilla. I go to speak about the CAM and our mechanisms. In your system, the CAM is one of the important parts. We can say it's the hairs of the movement. Uh, because without in noting would work properly. Its main jobs is to torque circular motions, the spinning from a motor or shaft into uh, to a back, force movement, kind of like swing. Uh, the swinging motion is it's not used for shock. It activates the four-bar linkage systems, uh, which moves the arms, and here's where timing becomes really, really, really important. Why? Uh, because the cam controls exactly when the arms should grab the cap, uh, when they should move it, and when they should let it go. Um, if the uh, if the if the timing is off the wall, uh, system can fail. The arms could grab too early or too late, or they midnight release at the wrong time. Uh, uh, since everything in your project is mechanical, we need use sensors or electronic controllers. We had to do a lot of testing. Uh, uh, we tried different can shapes and profiles, making small changes until we found the ones that worked best. We wanted the uh, motion to be as smooth and continuous as possible without jerks or stops.
Hi, my name is Walter, and I talk about for the application challenges and final throws by our project. Uh, in this type of system, I use it is used in many real life scenarios. Um, I can be applied in packaging, sorting, or assembling of small products. It's especially useful where an speed and consciency and low costs are required, aren't they? One big challenge was making everything work purely mechanically, and which wasn't easy, was it? A deep understanding of torque, gear, radius, backlashes, and motion timing was needed. Um, have you ever wondered why torque must be calculated so precisely in this system? Um, and another issues was faced when design, designing the arms. They had a hole, the cap very steady, and even small miscellaneous cold cause uh, the cap to fall or be miscellaneous and stopping the process. Uh, in the end, we learning a lot of not just about mechanic but also about teamwork and testing and solving real problems in the real life. But but did didn't we? We sometimes asked ourselves how well we were collaborating or what could be improved. Uh, this kind of learning experience isn't forgotten easily. We're really proud of this project and it has been appreciated by our peers and instructors. And but Mr. Thank you for watching this video about our project and this and see you later.